Hello, my name is Naor. I'm one of the co-founders of the DMARS organization, a platform for developing concepts, technologies, operation, and education in order to prepare for human presence in space. It is sponsored by ICA in Israel and by the Israel Space Agency. This talk is about the Israeli Young Astronauts Academy. It is a high school innovative program that teaches STEM by simulating Martian analog missions to conduct research at the Mars facility in Israel. This program was developed at the Davidson Institute for Science Education. It is the educational arm of the Weizmann Institute of Science. In this presentation, I am going to talk first and briefly about what is a space analog. Secondly, I am going to present you the DMARS facility in the Negev Desert. Then I will discuss the educational program we developed, and I will finish with our future perspectives. So let's start. The major challenges in future Mars missions will be the physical surface conditions which are harmful for life. A thin atmosphere that produces pressure at the surface which is less than 1% of that of Earth. Huge amounts of radiation and extreme temperatures are also a major challenge. The psychological conditions of long duration cruise isolation and the vital consumables are also causing a threat to the success of such missions. In order to overcome these challenges, we need to conduct analog research and training. So, what is a space analog? A space analog is a situation where at least one condition is similar to that found in an extraterrestrial environment. So, for example, the desert of Oman is an analog environment to Mars because of its geology and aridity. Antarctica is an analog environment to Mars because of the extreme temperature. But these sites are also simulating living in crowded conditions as a psychological analog to living in conditions in future missions. Space agencies have many analog facilities and missions. For example, NEMO, which is a NASA undersea analog mission for scientists and astronauts training for future missions. Desert Rats is an annual analog simulation to test technologies for space manned exploration. Other analogs are for academic and educational purposes, like High Seas, which is an isolated habitat near a Hawaiian volcano that run by the University of Hawaii. Commercial companies also execute analog simulations. For example, Project Moonwalk, which is a consortium comprises partners from the European Union. Its goal is to test technologies relevant for astronauts robot corporation. And the Austrian Space Forum, which is an organization that serves as a communicator for space industries to execute a long simulation each year in a different location in the world, and you will hear more about them during this lecture. So, now that you know what is space analog, let's hear about our unique analog. DMARS is an acronym for Desert Mars Analog Ramon Station, and you will see in a minute where is this Ramon Station located. But what I want you to know is that DMARS is an innovative organization that is dedicated to serve as an international hub for space explorers and for educational, scientific, and training purposes. It was designed to serve as template for space exploration simulations. To the right, you can see part of the Negev Desert, which comprises the southern part of Israel. You can see the rift of the Dead Sea continental transform, which accommodate motion between the Arabian Plate and the Sinai subplate. You can almost see Jerusalem here at the top of this mountain range, and you can see part of the Dead Sea, which is a pull-apart basin. The Ramon crater is this elongated 40 kilometers heart-shaped depression, and it is not an impact crater or a volcanic crater, but rather the world's largest erosion crater. It is starting at the top in Cretaceous carbonates and cuts deep down 500 meters in volcanic units and clays and evaporates of the Triassic. The DMARS habitat is located at the center of this huge crater. This hyper-arid environment and geology are analogous to many sites on Mars where such mineralogy and morphologies have been found. What also unique about the DMAR site is that you can get to this completely isolated area in just 2 hours drive from the Tel Aviv metropolis of Israel. In this slide, you can see the first habitat prototype design that has been built about 2 years ago. It already accommodated few analog exploration missions of scientists and of the high school student program I'm about to tell you about. You can see that we have succeeded to simulate many of the necessities of space exploration missions. For example, the crowded sleeping pods of the crew, airlock and EVA hatch, and the clean air chamber. As you can see, this facility was designed to be deployable, starting from an innocent box and growing in size to accommodate more area of the needs of the crew. We have so far demonstrated this technology few times in the past when we had to transfer the habitat from place to place. In 2017, we have won an open call of the Israel Space Agency to develop an innovative educational program in which youth in the 10th grade take part in a program that simulates astronauts' analog training. The program inspires from the real NASA training program and make use of this amazing method to teach STEM and soft skills for our future leaders. Over the span of 2 years, the group of kids learn and train to complete a final analog simulation mission, to explore the analog environment and to complete a set of scientific tasks. The final simulation makes use of the Mars facility in the Ramon crater for the span of few days. A group of 3 to 8 students enters the habitat together and start a completely isolated simulation which they have to run and manage themselves. There is a simulated time delay of 10 minutes between them and their friends in the Mission Control Center that is located somewhere else in the country. The kids train for a very long time before starting this mission, and all the roles and plans are set long before the mission starts. The students execute the skills they have acquired along the 2 years program in order to succeed in the exploration mission that has been given to them. In 2018, the first and second simulations took place. These two were the grand finale of the first cycle of the program. The students took part in the establishment of the Mars facility at the Ramon crater. In March 2019, another mission took place as the grand finale of the second cycle of the program, while they integrated a rover platform at the Mars facility. During the beginning of the pandemic in Israel, the two final missions of the third cycle were the last simulations that took place at the facility, as the kids started the isolation when it was still allowed to travel in the country and came out of the habitat to a completely different world, while Israel started the locking up of the whole country. Interestingly, up until now, we had more female students than males, which we are very happy about it, but still wonder why. The scientists and the student missions got international media cover, which I encourage you to search for over the internet and see that many other short programs and tours are offered as well. The Young Astronauts Academy is an innovative interdisciplinary project-based learning platform. It has been so far reported a once-in-a-lifetime experience. It proved well in developing the young students' soft skills, as they were encouraged to be independent, responsible, and collaborative. The method of space simulation has been proven so far as a unique mean of inspiration and engine for choosing STEM and planetary exploration-oriented career. The program has proven gender equality. Apart from the program that we discussed, the facility serves as a platform for a variety of activities for various ages and levels. I will very briefly talk about our next steps. which are to establish and test our new professional habitat base, which I will present in a minute. We plan to conduct more of the academic and industry collaborations, which I chose not to discuss here due to the session topic. Our next big thing is a joint simulation with the Austrian Space Forum in a mission named Amity 20, and we'll talk about this in a moment too. And I will also want to bring up what is next planned for educational purposes, which will also include tours and TV shows that will be filmed in the facility. The second prototype of our organization is already under construction. It was planned to be established in 3 stages, and we are now focused on the rigid part of the structure. In the coming years, we plan to add to the structure a growth mechanism, which is inflatable and deployable. Finally, in 2023, we plan to add a cover to the structure with in situ resources utilization material from the analog environment that surrounds the habitat. All of these steps have been made to prove the concept of a variety of plans for human bases on Mars. In this slide, you can see an illustration of this planned outpost. In this drawing, you can see how the structure is designed to look from the inside. The first floor is what we are building now, and the second floor of this first rigid stage will be joined later this year. This outpost is planned to be used in the joint simulation with the Austrian Space Forum. In October 2021, this international organization, which is focused on space simulations for commercial and scientific purposes, will conduct a 3-week simulation in the Ramon crater in cooperation with the Israel Space Agency. They will be using the DMARS facility in their 3-week simulation and are also planned to collaborate with the students of the Young Astronauts Academy that we have discussed previously. We plan to continue develop and execute educational programs that make use of the DMARS facility, including the Vanguard Young Astronauts Academy, which was the first and only high school student space simulation of this type that took place anywhere in the world. We welcome you to take part in the future educational endeavor by collaborating in the development of new programs or by taking part in one of these simulations. After all, did you ever see kids like these, which are so enthusiastically walking in the desert at 6 a.m. with their spacesuits on their way to conduct science? Please follow us over the social network, and I encourage you to contact us through connect@dmars.org. I would like to thank you all for listening, and with that, I will take questions.